back in the Miocene. Here I refer, of course, to the Basin and Range. The Basin and Range is a most extraordinary region of our continent, which seems to continue to be opening. Is it possibly an ocean of the future? That's for the future to know. But we do know that all of these things are going on, coincident with a stoppage of subduction. So here you have subduction here in the north, pretty normal. The Juan de Fuca remnant plate is going down, and the Cocos plate down here. A little set of mid-ocean ridges, interestingly enough, evolved or developed in through here, which has torn the Baja leg off. And if you look at where the Baja Peninsula is, in Mexico here, you can see its north end, the north end of the Baja California, this bight, this bay, it really extends just up to the bottom of the Basin and Range. So one can easily conceive that this will continue into the future with this becoming a seaway, a continuation of the Baja. And all of this is showing the extension, the pulling apart. So here comes an extremely important statement, if you remember nothing else about it, you should remember lots more, but about the American West, is that after a couple of 100 million years of compressive tectonics, that's Antler and Sonoma and Nevada and Sevier and even Laramide was all compressional. Now in the Neogene it changes to extensional tectonics over much of the area. So there are two big things to remember if you want most take-home points about the history of the West. In the Neogene, there was regional uplift, probably due to isostatic pop-up, and there was a change from compression to extension. If you remember that phrase, then you remember a lot about the Western interior. Now, maybe that other cartoon is just as good, and it's mimicked by a little one I passed out, but it's hard to read it on the little one, so study it on the slide, that slide. But this is even the one I try to give you. What are the regions of the American West? Well, here I said the Neogene tectonics produced about 9 regions, okay? If you remember those 9 regions and what they mean, then you've got the history in the last 25 million years of this whole big stick-thin region. Those areas that you should know are the Rocky Mountains. We'll go through each one in detail. The Colorado Plateau, the Basin and Range, Sierra Nevada, the Great Valley of California, which is just there by default. Coast ranges, which extend up here. And then in the north, the Cascades, Columbia Plateau, and Snake River, Yellowstone. If you know those 9 areas, then you've learned a lot, and you're going to learn all in the next few days. Over the weekend and right now. So I'm going to go through these. Let's start with the easternmost belt, the Laramide. The Laramide belt, or the Laramide uplifts, were already there. Don't get me wrong, they started to form by compression during the Cretaceous, the very latest Cretaceous, and the Paleogene. And they were these kinds of large basement uplifts that we call thick-skinned tectonics. One major swath of those is the Front Range that runs right up through here, almost north-south. You can see it on any map. There are some other odd block uplifts that include the Black Hills, the Bighorns, the Wind Rivers, and the Wasatch. These are all, and oddly enough, the Uintas, which run east-west. Well, you should start to learn those different ones, and you're looking at the maps. I'm very pleased to see people studying those maps. But here you have this. Now, but the thing to notice is that we have now evidence that by late Eocene and Oligocene time, those block uplifts were worn down and completely filled in around with their own debris. Let me see if I've got some pictures here. I'm going to skip that one for now. I'm going to show you on Monday some more scenery. But here you can see modern uplifts. This is the Bighorns. You can see they're pretty dramatic mountains, so they've got big, steep valleys. And here you can see the backside of those same Bighorn Mountains. That is Eocene age debris filling right up, but we know from little remnants found way up high that debris originally extended up to here in Eocene time. In other words, just like on our east side, there was a penoplanation which had pretty much just eroded things down to a sloping, gentle plain going down to the Mississippi River by the end of the Paleogene at least. But that's not the way they look today. You can see they're sticking up. There's been hundreds of meters of removal of this soft gunk, this soft basinal sediment, which, by the way, is all this yellow patchwork you see on the maps. I'm sure I asked you that looking at one of those maps. And that is the intermontane basin fill, including the Green River shales and a lot of the other stuff. It isn't all removed, but a lot of it is. Here's the Front Range itself. As you drive into Denver, this is what you see. You're coming smack out of the plains. There's a Front Range fall. That's probably early Cenozoic, but the modern relief of those mountains, of those glacially cut pinnacles of Precambrian rock, that owes itself to what happened in the Neogene. And that is regional uplift. Here's a very famous locality, the Garden of the Gods, where you actually see old strata from the Pennsylvanian ancestral Rockies, which were subsequently rotated upward into a vertical position by the modern Laramide, and then etched back out in the Neogene time, because they were probably buried in their own sediment, and now exposed. And you see this also. These are just scenes near Denver. So there was this near burial that you see, but it's not true anymore. What happened in the Neogene is that whole region popped up. I think the best explanation is the peeling away of the Farallon slab, and the whole area starts to come up. And as it comes up, the rivers that are just there and sluggish and meandering start to cut ever more deeply and more rapidly as the area rapidly comes up. Okay, and here's a really important thing. This is Glenwood, Colorado, where the Green River is punched right through one of the great ranges of the Rockies, right here. Now you would look at the map and you'd say, wow, there are plenty of ways that rivers can go around those uplifts because they're not continuous, not like the Appalachians. Why didn't the river go out around? Instead, it has punched right through. This is the result of superimposed drainage, meaning the river was already there and the land rose up. It could not just move the river, so it had to cut deeply down into the rock. And that's what you see. It's a deeply incised canyon cutting right through a part of the Rocky Mountains. The Rockies, as we know today, would not exist if it were not for Neogene regional uplift. This is the point I'm making here. All the spectacular scenery of the West would be just a subdued, gentle, high plains like this stuff if it were not for what happened. Let's go to the next region. The next region out of the 9 is the Colorado Plateau. It shows up beautifully on any map, and everybody should be able to identify the Colorado Plateau. Click it for a minute, but I'll be getting to that just momentarily. Here's the outline of the Colorado Plateau. It's situated on the Four Corners. It's not really centered quite on the Four Corners, but it is in the states of Utah, Colorado, New Mexico, and Arizona, the so-called Four Corner State. It's not exactly circular. It's in an ovoid area. What do we know about the Colorado Plateau? It has some of the thickest crust in North America, and we believe that during the Laramide orogeny, it acted almost as a rigid plunger which pushed in to help push up the Laramide uplifts all around its margin. Here's the Front Range, here's the Uintas around here, and it may have even rotated a couple of degrees. But what happened in the last 10 million years in the Colorado Plateau is unprecedented. That area has risen up by several kilometers. Okay, it's come right up out of the ground as a rigid block, probably because it has deep roots. And as a result, this rigid block, which never really experienced a lot of the tectonics that were going on all around it. In other words, you've got Rockies all around it, but here, very little actual deformation in the Colorado Plateau. The stuff is almost flat-lying. But what makes the Colorado Plateau North America's greatest scenery? And you must know that the most concentration of national parks in our country is in Utah, and some in Colorado, some in New Mexico and Arizona. It's because of the Colorado Plateau's scenery. It rose up dramatically during this time in the last 10 to 15 million years. And so rivers that were already there cut down deeply. It's like you're feeding a log into a circular saw, and it's just chopping right down through it. And here's the most famous region, of course, that is Grand Canyon. And Grand Canyon is nothing but erosional scenery, really. At the bottom, by the way, there's Precambrian. At the top is Permian. And a sort of poor Paleozoic section in between. I'm not all that hot because it's got so many unconformities, but it is very famous. And the next picture shows it again. And I think Yeah, the Colorado Plateau, shown right there. By the way, this is the very edge, not too far from Grand Canyon. This is the edge of the Colorado Plateau. Flat-lying sandstones on the horizon, you see. Grand Canyon, the most famous of all the erosional scenery, of course, more than a mile deep, and you should remember it's cutting into the Precambrian Vishnu schist at the bottom. Great unconformity here, and this abbreviated section of Cambrian, Mississippian, and Pennsylvanian Permian. No Devonian, no Silurian, no Ordovician. What good is it? Okay, you know I'm a little biased. Okay, so another place. Really, you can see very, very clearly what's happened here, because this is a meandering river which is entrenched. It's called an entrenched meander. And in an entrenched meander, you're seeing evidence that that was a sluggish stream flowing on a low gradient at one time, and then as this whole region popped up, it has cut deeply. This is called Dead Horse. I'll tell you on Monday a little story about Dead Horse. And here is a very famous national park, which is, of course, Zion. And Zion, you have Jurassic sandstone being cut into by these by the forces of erosion. It's just erosional scenery, but it's erosion facilitated by the bottom coming up in an incredibly rapid trajectory. There's also from the famous section at Zion. That's Jurassic windblown sandstone, as you should know. And this is the youngest sediment cut. It's Eocene age, Wasatch Formation, and it's being cut at Bryce Canyon National Park. On Monday, I'll review all the national parks. I don't have time right now. Okay, so this big block called the Colorado Plateau, having sat there in the crust, now makes this big excursion uplift. Even at the same time the Rockies are uplifting. What about the area to the west? The area to the west of the Colorado Plateau, which is region number 3 out of 9, you should know, is one of the most peculiar features in our craton. It is the Basin and Range. And the Basin and Range was formed during Neogene time, starting in the Miocene and continuing really into Pliocene, maybe a little bit into Pleistocene. This area is fragmented. It is a series of rift grabens, in which the rifts, well, again, not really time to get into this, but they're so-called listric faults. If you've taken structure, they're actually sort of doing this. They're steep at the surface and going more sub-horizontal at depth. Some of them are probably even reactivated old severe thrusts. But during this time, you see a whole nest of these north-south running faults. Now, this is again a cartoon, which may not be so easy to see from the back, but this is sort of a little nutshell view of the history of this region. You'll notice thrust faults. This is in the severe desert, and these are the so-called severe thrusts. They're Cretaceous age, and they're obviously compressional, but they're cut by normal faults during the Neogene. So, compressional, Cretaceous, severe thrust faults, cut by normal faults, gives you a little bit of a capsule summary of what happened in that area. After lots of compression, there was finally an extensional event. This is what it looks like out there. This is Severe Dry Lake, where the name Severe comes from, actually, for the severe thrust. But what you see here are Paleozoic rocks in one of the ranges. This is what one of the basins looks like, quite arid. That's a salt lake sitting down in it. Of course, Salt Lake itself is in one of these big basins of the Basin and Range. The basins here refer to graben basins, and the ranges are horst blocks. This is what it looks like in a satellite image. It's very distinctive. Bing, 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 bing. All of these north-south extending normal faults, which bring up blocks of crust, or I should say, in between is collapsed crust. What really happened in the Neogene, we think, was first the thermal doming, so this area domed up, and then it split apart and collapsed. And it's continuing to collapse to the present day. And you can see it really does continue right down into the Gulf of California here. So this whole region is, as I told you, is expanded by twice its original width, just in the last, say, 10, 15 million years. That's quite an impressive thing. There's, by the way, another branch that goes down around south of the Colorado Plateau and comes up in here. It's called the Rio Grande Rift. The Rio Grande Rift coming up around the other side. And there's the Colorado Plateau, like an island of stability, surrounded by all kinds of. Fourth region that you should know about. Let's see what I have. Yeah, fourth region. There's Yosemite for for background, is the region called the Sierra Nevada. When you come to the western edge of the Basin Range, you hit the Sierra Nevada. The Sierra Nevada is, if you'll remember, something we've already talked about, because during the Mesozoic time, during Jurassic and Cretaceous, this was a magmatic arc. But this also means that the rocks you see in there are granites. Oops, you've got all your post range on me. Every time you shut it off. Yeah, are granites and granodiorites that form deep within the earth in magma chambers. They wouldn't be exposed at the surface if it were not for what happened in the Neogene. But even as the Basin Range was collapsing to the west, this great block popped up, and it came up very fast. And it forms one of the great barriers in the American West because the Sierras are so high. It's hard granitic rock with only a few passes, like the famous Donner Pass. Sounds like it's going into its dying phase there, so you better shut down. This is the Coast Ranges. I'll get to that in a moment. We'll go ahead and click it down. Click it down. Let it cool. Maybe the fan can stay on. So there is this region, and we know it's an uplifted old batholith or magmatic arc. Next to it is the Great Valley. The Great Valley is, of course, an area which we see on any map as a flatline area of quite thick sediments. It's a four-arc basin, an old four-arc basin. But the Great Valley itself was uplifted above sea level during the Neogene. And finally, you come to the Coast Ranges. Hopefully that picture is still subliminally on your mind. There it is, the Coast Range, rugged ranges of California. You go underneath the Golden Gate Bridge, and you see the rocks there are mostly chert beds. Yeah, go ahead and shut it. And leave it off for now. So this is the area which was once an accretionary wedge, which is now uplifted, but it's also shot through with strike-slip faults because it's part of the San Andreas complex. It cuts right through the Coast Ranges. So the fifth and sixth regions you need to know about are the Great Valley, the four arc of the Mesozoic age, but now uplifted, and the Coast Ranges. Okay, let's go to the north, and if we look here, and again I had some nice pictures, I don't know if I dare to show them. You have the Cascades Range. The Cascades Range is along the coast, inboard from the coast of Oregon, Washington, and it is an active magmatic arc. In many ways, it's kind of the northward extension of the old Sierra. But up here, for whatever reason, the subduction has now turned back to a more reasonable, steeper angle, and the Cascades represent a magmatic arc. Here you can see what's happening. The Juan de Fuca plate, that last remnant of the old Farallon, is subducting here, and as it subducts, it's creating a magmatic arc right through here. And you can see some of the famous names. Here's a cross-section. Nothing particularly striking about that. It's a classic Andean margin, and these are classic andesites. Very explosive volcanoes, as you know. St. Helens blew its top around 2000, and they're all very potentially dangerous volcanoes. It might be, seem like nice Starbucks country out in Seattle, but be aware. When you live in Seattle, you go to the risk of these eruptions. If Rainier, shown here, one of our great peaks of these volcanoes blew off, not only would Seattle go down, but probably much of our western part of our country would have a huge catastrophe. And it's certainly possible because in the past these have blown their tops, and they are very explosive types of volcanoes. We're just now in this other gentle time, and everyone, hippies, former latter-day hippies lives out here. It's just wonderful. But geologically, it's a hazardous place to live. Here you can see some of the famous ones. You've heard of St. Helens, you've heard of Baker, Glacier Peak. Rainier is the biggest and most famous, probably around right near Seattle, threatening Seattle, and all of these. They continue down into northern California with Lawson Peak at the south, and go up to Mount Baker up here. So it's a pretty good long string of volcanoes resulting from this subduction. Okay, and as if that weren't enough, when you go to the east, there, you come to this thing that I call the mitten. Why do I call it the mitten? Because it's got this big blobby hand, which is orange here. That's Miocene basalts. And it's got the thumb that sticks out here. cutting right across the old Severe Belt, right through there. And that thumb is also volcanic, and it ends at Yellowstone. The end of the finger, a burned out hole at the end of the thumb of the mitten, is the Yellowstone hotspot position. So, in addition to all the tectonics going on, there was a strange overriding. So here's the Cascades. There was an overriding in Miocene time of a hotspot. This produced an enormous amount of basalts in this area. Somewhere I wrote down about how much. Sorry, I'm way off from these sheets, but you can read them on your own. Yeah, the Columbia River, Snake River Plain. Let's see, I summarized all this crap on the sheets. But the Columbia, I just have to go back to this because I've never remembered. These came out as gigantic flows as much as 30 meters, 100 feet deep, over 100 kilometers spread, moving at 5 kilometers an hour with temperatures over 1,100 degrees centigrade. And in total, over 3.5 million years, they put down about 300,000 cubic kilometers of volcanic material. There was minor extinction at this time too, but it isn't something we write home about. It's not a big deal, which is amazing when you think about it. This kind of volcanic activity you'd imagine would produce great effect. Here you see it along the Columbia River, and these are called the Columbia River flood basalts. One of the greatest times of flood basalt in our history of our continent. And you see layer after layer after layer of these Columbia basalts, cut into, by the way, and we'll hear in the final saga, cut into by an enormous flood which affected this region in the Pleistocene. But here you just see the basalts. If you sort of move to the southeast, you come into the Snake River Plains. And the Snake River extrusives are a bunch of, again, flood basalts, but they're not as extensive as up here. That was, of course, the older time. You see how big it was here. And now this is extending as the thumb of my famous mitten, the pink thumb on this map. And that pink thumb is Plio-Pleistocene age basalts, and not all basalts, some rhyolites too, more granitic. Going back here, and it ends, it ends over here now. And it is, in fact, a classic example of a hotspot trackway. But if you look at it, it's a little unclear what happened in the earliest history. It looks like there was a huge ballooning of a hotspot here, and then it shifted abruptly at around 15.5 million years ago. So during the Miocene time, it's poured out the Columbia River flood basalts, then it shifted down to here, actually about 16 million. And then you can look at this. This is incredible. Just like the Hawaiian Islands, 16, 15, 14.7, 13.8, 12.5, 11, 10.3, 6.2, 4.3, 2.0, 1.3, 0.6, the Yellowstone caldera, another very dangerous place in our continent because, again, it's underlain by the hotspot itself today. And this is a classic hotspot trackway on a continent. But on the continent, it's going to ultimately melt some continental crust, which makes for much more explosive type of volcanoes. And I'm sure everyone has informed you that another critical spot in our craton that could mean that pretty much the end of North American civilization, if it really blew as it has done, is the Yellowstone hotspot. That could blow its top, and that would not be good. But meanwhile, it's a pretty place to visit. It's called Yellowstone National Park. Now maybe try it one more time and see if it's back on. Yeah, so here again, the mitten right there. First of all, before that, there are the Cascades. They're not part of the mitten. They are just normal Andean-type magmatics. There is Great Rainier. Oh, bow down to Rainier. It's a big giant with potential to do a lot of damage. But whatever, that's the way life is on an active planet. Here you can see the Snake River Plains. So now we're into the mitten. This is the big area of orange here. This is the Columbia River cutting into it. And of course, Yellowstone itself. And I think my final slide, yes. Old Faithful, this hydrothermal activity there tells us that there is a hot spot close below the surface and potentially it's very hazardous. All right, so I'm going to take a 5-minute break. I'll come back and we'll wrap this whole thing up.